Hello, 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 welcome to today's lesson. Today we are going to look at a topic called portfolio. It's a very interesting topic. It's called portfolio theory. So first of all, we need to understand what portfolio is and what it entails. Every time someone talks about portfolio, especially in business, the person is talking about a collection of investments. A portfolio is a collection of investments. So according to this theory supports the aspect of having different investments, a collection of investments. And in this theory, a collection of investments means that there is need for diversification of investments. That means that we cannot rely on one source in terms of investments. If it is a company, it needs to have several sources of income or several investments. When you look at investment in that form, it means that actually most companies have implemented the aspect of portfolio. If you look at Safaricom has grown from SMS to calls to Fuliza to M-Pesa to Paybill to everything that you can call in terms of investments. That is what it means when you talk about portfolio or diversification. So, portfolio theory supports the aspect of investing or having several investments. I hope now you've understood that concept. So, in terms of investment, if you're in the telecommunication industry, we can have a collection of investments in that telecommunication industry. If you are in real estate, we also can have a collection of investments in that real estate. There is also the aspect of correlation whereby you do not invest in one area but you diversify. That means that you can be in real estate, at the same time you can be in finance, investments, maybe stocks, shares. At the same time you can be doing farming. At the same time you can have a pharmaceuticals company. That is what we mean when you talk about diversification. So we are going to do some calculations, and I'm really hoping that you can be able to finish this topic today. So We are going to start with the first mathematical formula that is very, very important. It is called portfolio expected return or expected portfolio return. I wanted to present the, I don't know if I'll be in a position to do that. I wanted to present the presentation for portfolio I don't know if it will be possible. Let me close that, then I open this window. Yeah, that is it. So we have talked about the theory, also about the diversification. So let's come to portfolio expected return. We have a formula, this formula here, E into brackets RP is equals to E into bracket alpha XA plus beta XB. So this formula is not difficult. Actually, when you apply it, you'll see how easy it is. So this ERP stands for expected portfolio return. Just as you can see, ERP, expected portfolio, for this small p, return, expected portfolio return. Then you have this alpha is the investment in asset A. Beta, this one, is the investment in asset B. Then you have XA is the expected return of asset A and expected return of asset B. Then alpha plus beta should give us is equals to 1. Alpha plus beta is equals to 1. So that formula, I know if it is the first time you're meeting it, it can seem very difficult, but it's one of the easiest formula. So consider two investments, A and B, each having the following investment characteristics. So we have investment, we have proportion, and we have the expected return. Why are we talking about portfolio expected return? Anytime you make an investment, you expect a return. So the return can be 10%, 20%. So there is an expectation anytime you make an investment. So that's why we are talking about the expected return. So here we are talking about two investments, A and B. For example, you've invested in real estate and you've invested in shares. And the proportion of your investments is 2/3, 1/3. This proportion can be, maybe you had 100,000. So 2/3 of that you invested, that is the proportion. You invested in the first investment. And then a third you invested in the second investment. And this is the expected return. So here you're being asked, compute the expected return of a portfolio of the two assets. Now we want to know what is our expectation in terms of return of these two investments. What do we expect to get in terms of return for these two investments. So basically what you do, I don't know if the calculation is here. Yeah, it's here. It's very easy. So what you do, actually you don't want to dwell on the formula because there are no marks for that. So the calculations are very important. So you'll just say this 2/3 times 10, don't forget the percentage. 2/3 times 10% plus 1/3 times 20% is going to give us the expected return of a portfolio. You see how easy it is? 2/3 into bracket 10% plus 1/3 into bracket 20%. If you do this calculation, 2/3 times 0, actually you just do it using your calculator. 2 divided by 3, whatever you get, times 0.1, you're supposed to get, when you add, you're supposed to get the expected return of portfolio as 13%. Up to there, is there any question about expected return of portfolio? Or clarification? Any question? Okay, so let's assume that we are good. So let's proceed. So that is the first subtopic. Our first subtopic is portfolio. Let me go back. Our first subtopic in this topic called portfolio theory is portfolio expected return. So I want us to go to our second subtopic. If you're writing, it's good to write these subtopics. Our second subtopic is called expected return of individual securities. Expected return of individual securities. Individual securities, that is our second subtopic. So this one, we'll use a question. Consider the following. Assume you have the opportunity of investing your wealth in asset X and Y. The possible outcomes of the two assets in different states of the economy are as follows. So we have the state of economy, high growth, normal growth, slow growth, stagnation and decline. We also have the probability. Probability is the same as proportion. Of course, probability can never be more than one. So the probability is this. Then you have returns in percentage X and Y. So we have the returns for this, for X in percentage, and the return for Y. Then you're told compute the expected return of individual securities RX and RY. That is what I want us to look at. The expected return of individual securities. And part 2, the expected return of portfolio. Kindly know that there is a difference between expected return of individual securities and the expected return of portfolio. When you talk about expected return of individual security, here we have specified that we are looking at one investment. But when we talk about expected return of portfolio, here we are talking about a collection of assets. So kindly, it is good to know the difference and to note the difference. And you must know what you're being asked. If it is the expected return, for example, you have invested in real estate, you have invested in shares. Now you want to know what is my uh, expected return of individual securities. For example, I want to know what am I going to get in real estate in terms of returns. What is my expectation in shares in terms of return, each separately. But when you talk about now expected return of now my portfolio, we are talking about the expected return of both real estate, shares, maybe farming, or also other investments. So it is good to note the difference between expected return of individual securities and expected return of the portfolio. So the calculations are, I'm going to stop this presentation, then I share the calculations. Yeah, so this is the question. So you're going to start by computing the expected return of individual securities. So we have Rx and Ry. So that is asset X, this one, and asset Y, this one. So what we do, actually I told you that you should not stress yourself with the formulas, just know the concept. So we are going to take the probability 0.10 into bracket negative 8%, like that, plus 0.20 into bracket 10%, and kindly don't forget the percentage, plus 0.40 into bracket 8%, plus 0.20 into bracket 5%, then 0.10 into bracket negative 4%, and you add everything, you're supposed to get the expected return of Rx as 5%. So here it is good to show all your calculations. So I've not shown my calculations, but it is good to show them there. Then you go to Ry, the expected return of Ry. This is the Y. We start again, 0.10 into bracket 14% plus 0.20 into bracket negative 4%. Don't forget about the negatives because they are going to alter your calculations. Plus 0.40, this one, into bracket 6%, plus 0.20 into bracket 15%, plus 0.10 into bracket 20%. That is the expected return of Y. And you have already answered part 1. Let's go to part 2 so that in case you have a question, let me know. The expected return of portfolio when 20% of your total wealth is invested in asset X and 80% in asset Y. So for portfolio, 20% is invested in asset X. For portfolio, we normally take the 20% times the expected return, which is 5%. So 20% is for asset X. So 20% into bracket 5% plus the next one is 80% invested in asset Y, 8%. So 8% is the expected return. So now I hope you're getting the difference between expected return of individual security and expected return of portfolio. From there, 20% times 5% should give you that. 80% times 8% should give you that. So that means that we will have our expected return of portfolio as 7.4%. So is there any question up to there? Any question or any clarification? So, these marks are so little, but no problem. So, there is a question here. The following information relates to two potential investments, namely S and Q. So, we have the probability and we have the return. We also have the probability. We have investment S and investment Q. The good thing is that the returns, you have been given the returns in terms of percentage, so this one becomes easier. The expected return of each of the two investments, each. So note the difference between the expected return of each of the two investments and the expected return of the portfolio. So each is separately. So very fast, I want us to do this question. I hope we can be able to do the whole of it. So the marks are not always very little like this. You can get this question having 15 marks, but even if it is 10 marks and you know the question, you're in a better position. So very fast, I want us to start with investment S. Give us the expected return. So for this question, by the way, you can do it horizontally or you can also do it vertically. So you can just say 0.3 times 20%, just the way it is. Then you write the answer. This times this, write the answer. This times this, write the answer, then you add. I can see the answers are flowing. So if you finish the first one, you can go to the second one. So you can see the first one you're getting 8%. Let's proceed to the second one. %8 again. Last person to confirm, or anyone getting a different answer. So we can calculate portfolio, expected return of portfolio. Is it possible to calculate of portfolio? Let us use expected return of portfolio when investment S is 30% and investment Q is 70%. 30, 70, 100, yeah. So 30% and 70%. Let's see what we're going to get. What are we getting as investment portfolio? So I can see 30%. For portfolio, we are using both. So here we are getting 8% and here 8%. So this is what I'm telling you to calculate. So for portfolio, we are going to say, so we have 30% and here 70%. So 30% times 8% plus 70% times 8% again. That is for portfolio. So let me show you. So for portfolio, we were taking, so if you're given here as 30%, so you're going to say 30% times the expected return was 8% plus 70% times 8%. And then you're supposed to get your answer as 8%. 8% should be the answer for expected return. This is what I was asking, expected return of portfolio when 30% of your total wealth is invested in asset, I think in this case is asset S, and 80% in asset Y. So I want us to look at another subtopic. Our next subtopic is called standard deviation. Standard deviation. Is there any question or clarification? Okay. So we can proceed to standard deviation. So for standard deviation, there is a formula that we need to use. We are still going to use the same question, this same question, and calculate standard deviation. So for standard deviation, we are going to say that the formula is the square root of summation of x minus x bar squared times p. So we also have standard deviation of individual securities, and we also have standard deviation of portfolio. So for now, we're going to start with standard deviation of individual securities. So I really hope that you can be keen so that you can be able to get the concept. So the formula is not difficult. So I told you that don't worry about these formulas. For FM, as long as you're able to apply the formula correctly, there is no mark for writing all this, as long as you'll be able to apply the formula. So what we are doing here, standard deviation of x, we take the probability, here you can see P, so probability, so we are starting with x, so you just come here, we are starting with x, so the probability is 0.10, which is the same as 0.1. So you take the 0.1 into bracket negative 8 minus 5. So x stands for return, x bar, you can see this x, and line stands for expected return. So return minus expected return. So the return for x, we are starting with return negative 8% minus the expected return 5%. So negative 8% minus 5%. And here we can just ignore the percentage and then you're going to apply them later. So that means that squared, don't forget the squared, return minus expected return, plus you go to the next still under x, the next is 0.2, so that means that it will be 0.2 into bracket return, which is 10, minus the expected return of x, which is 5. So we still do again 0.2 into bracket 10 minus 5 into bracket square. So you do the same for all of them up to the last one. Return, the last one is negative 4. You start with the probability 0.10 into bracket minus 4 minus the expected return 5 into bracket square. From there you add everything, then you're supposed to get the square root. Square root gives you standard deviation of x. Then the same thing applies to standard deviation of y. You still do the same. So here I've not shown the square root yet. So you can decide to do it horizontally or you can also do it vertically. Vertically is where you just write this and you write the answer. Come down here, write 0.2 into bracket minus 4 minus 8, write the answer, then you add everything vertically. Whatever you get the square root for you to get the standard deviation of y. So for y, return minus expected return. So we have 14 is our return. Our expected return is 8%. So we have probability is 0.1, return 14 minus return minus expected return. Our expected return is 8. So you come here and say 0.1, 14 minus 8 into bracket square plus 0.2 minus 4 minus 8 into bracket squared plus 0.46 minus 8 into bracket squared. Whatever you get the square root, then you're supposed to get the standard deviation of y. That is how you're supposed to work that out. So I just want us to go so that slowly, so that you can be able to get the concept. So I want us to calculate the standard deviation of each of the two investments. We have investment X and investment Q. The standard deviation, we have said that you take probability into bracket return. So you can still do it like this, vertically, so that you cannot mix up. So 0.3 into bracket return 20%, the expected return for each investment. So we got 8%, then get the squared. So let's start with the investment S. So part 2, we are calculating the standard deviation. So tell us what you're getting as the, don't forget to get the square root, as the standard deviation for investment S. Hello. Hello. Oh. Sorry. Well, you're getting 0. So what are you getting as your answers for standard deviation? Yes, Caroline?
Okay, Grace, I have a question. I think I'm a bit lost on standard deviation.
Okay.
Are we supposed to do the investment S minus the expected return from the actual return we have for X separately, then for Y separately? Or, and then after that, do sort of like, how do we do, what do we do after we do the standard deviation?
Okay. So let me go back here so that I can clarify that. First of all, in the question, you are told the standard deviation of each of the two investments. The same way here you are told the expected return of each of the two investments. That means that you'll start calculating the standard deviation for investment S. After you finish, you go again and calculate the standard deviation of investment Q. That means that we are calculating the standard deviation for investment S separately, and then standard deviation for investment Q separately as well. That is point number 1. Point number 2. How do you calculate standard deviation of investment S? This is what we've said, that you are going to take the return. So the formula is this one. Return minus expected return. This X bar is for expected return. Times probability. And then you are going to add everything. And don't forget squared. So let me just give, because I am not seeing anyone who has done it. So we can start with this one. We want to calculate the standard deviation for investment S. So you can write 0.3 into bracket return, which is 20, minus the expected return of S, we had it as 8% squared. So 0.3 into bracket 20 minus 8 into bracket squared. So you can write it vertically, hivi venye iko vertically, we are going downwards. So the second one will be 0.4 into bracket, the return is 8%, but we are going to use 8, minus the expected return is 8 as well, squared. The third one is 0.3 into bracket -4 minus 8 into bracket squared. So we start with the first one. 20 minus 8 is 12. 12 squared times 0.3. Eight minus 8 is 0. 0 squared is 0. 0 times 0.4 is 0. -4 minus 8 squared times 0.3. So what are you getting? Yes, Rosaline?
Asking Madam Grazer,
Yes.
when you work out this, the 0.2, the 20% and the 8% as
You don't work it as a percentage. So, for example, which one have you used? Okay. So, what are you getting? Maybe someone can tell us, because personally I've not used percentage. Anyone who has used percentage? You see here, we were not using percentage. So you just take negative 8. Maybe I can share what I have so that we can be on the same page. Personally, I have this. So, or we can start. Don't see if we can finish this topic today. And I don't want us to rush it. So let's do this. We can still meet tomorrow and still continue. So, but here don't use percentage. but you're supposed to get something to do with 9.3%. So still, or we can proceed to investment Q. So you take 0.2 into bracket 20 minus 8 squared, 0.6 into bracket 8 minus 8 squared, 0.2 into bracket negative 4 minus 8 squared. Eight minus 8 is 0, so 0 times 0.6 is 0. So I think we can Jen, you're getting 0.93. Did you use the percentage? Times 0.3. Is it 423 or 432? 432. That means that because if you're getting 0.93, when you convert it into percentage itakuja 93%. Sasa hapo ndio shida inakujia, because the standard deviation should be 9.3. Yeah. So that's why I'm encouraging that we don't use percentage. So that you can get. So let me share my workings for standard deviation. And also remember, but you see you're getting 0.93 and I'm getting 9.3 if you don't use percentage. So let me share what I have. But for the last one, coefficient of variation, maybe you can write the formula for coefficient of variation so that you can start on something different tomorrow. Formula for coefficient of the variation, if you're writing, you can say coefficient of variation is equals to standard deviation over expected return. coefficient of variation equals to standard deviation over the expected return. So we can start from, you can pick it from there in our next lesson. I wanted to move fast, but I saw there is no need for us to move fast, and then you do not understand the concept. So let's meet tomorrow so that we can be able to finish this topic tomorrow. We can be able to do maybe more examples and finish it tomorrow. Then we pick it from there. Thank you so much. I hope you'll be able to go through what you have learned. In case you've missed any point, at least then tomorrow we can be able to meet and proceed from there. In case you have any queries, kindly let me know. Thank you so much. Let's meet tomorrow.